In this video, we are going to discuss few problems on applications of Laplace transforms for solving differential equations. First problem, using Laplace transform, solve y double dash minus 3y dash plus 2y equal to e power minus t. Given initial values are y of 0 equal to 1 and y dash of 0 equal to 0. Before we start to solve this problem, first you should know about these two derivative formula which is given in green color. First one is L of y dash of t, first derivative formula. L of y dash of t equal to s into L of y of t minus y of 0, and L of y double dash of t equal to s square into L of y of t minus s into y of 0 minus y dash of 0. First thing, you should remember these two formula, then only we can easily solve the problem. What is our given differential equation, which is y double dash minus 3y dash plus 2y equal to e power minus t. These are the given initial values, which is y of 0 equal to 1 and y dash of 0 equal to 0. In step 1, first we are going to apply Laplace transform on both sides in the given differential equation and also write in terms of t, which is L of y double dash of t minus 3 into y dash of t plus 2 into y of t equal to L of e power minus t. Okay, and also using linearity property, we can split into three terms. First term is L of y dash of t minus 3 into L of y dash of t plus 2 into L of y of t. Each and every term apply Laplace transform with the help of linearity property. Equal to right hand side value will be same, which is L of e power minus t. As I told you before, now we are going to use these two derivative formula. First one is L of y dash of t, second one is L of y double dash of t. What is our first term in the question? L of y dash of y double dash of t. Now apply this result here, which is s square into L of y of t minus s into y of 0 minus y dash of 0 minus 3 into L of y dash of t is there. We know that L of y dash of t is, this 3 is common, minus 3 into 1 open bracket s into L of y of t minus y of 0, close the bracket, plus 2 into L of y dash of t is there in the given equation right here, equal to L of e power minus t. Now we are going to apply our given initial values. What are the given initial values? First one is y of 0. See, look at this, y of 0 equal to 1 and y dash of 0 equal to 0. See, look at this. First term is s square into L of y of t minus s into y of 0 is there. What is our given initial y of 0 value is 1. Substitute here s into 1 minus y dash of 0. Y dash of 0 value is 0 minus 3 into, this 3 is common for these two terms. 3s into L of y of t first term, second term minus into minus plus 3 into y of 0. What is y of 0? Given value, initial value is 1, 3 into 1 plus 2 into L of y of t equal to, we know that L of e power minus t is 1 by s plus 1, because the general formula is L of e power minus at equal to, we can write 1 by s plus a. Here a is 1, therefore 1 by s plus 1. Okay, in the next step, in the first from the first and also fourth term and also in the last term, from these three terms taking outside common L of y of t. L of y of t is common from these three terms. Here s square is there, right here s square minus 3s plus 2, right here plus 2, and then rest of the terms here minus s, written here minus s, 0, we can omit this one, plus 3 into 1, which is 3, equal to 1 by s plus 1. Okay, now we can write L of y of t into, write this term s square minus 3s plus 2, and then this minus s plus 3 goes to right hand side. which is equal to, we can write 1 by s plus 1. Left hand side minus s is there, in the right hand side it will be plus s, left hand side plus 3 is there, right hand side it will be minus 3. Now taking cross multiplication for these two terms, it will be 1 plus s minus 3 into s plus 1 divided by s plus 1 equal to, we can write, multiply these two terms, we are going to simplify this one. S minus 3 into s plus 1 is, taking multiply these two terms, which is s square, s into s square, 1 into s minus 3s minus 3, which is equal to, we can write s square minus 3s plus s will be minus 2s minus 3 is there. Here 1 is there, no, if you are adding that one, it will be s square minus 2s minus 2 written here, okay, divided by s plus 1 is there. In the left hand side we are having 1 s square minus 3s plus 2 term is there. Now that left hand side term goes to right hand side, it will be in the form of L of y of t equal to s square minus 2s minus 2 divided by, here 1 s plus 1 is there, right here s plus 1, left hand side this s square minus 3s plus 2 is there, no, this comes right hand side, we can write here, okay, which is equal to s square minus 2s minus 2 divided by s plus 1 only. For this quadratic equation, we can write in the form of s minus 1 into s minus 2. Here the roots are 1 and 2 for this quadratic equation. We don't have any direct formula for this Laplace transform value. That's why with the help of partial fraction method, we can easily simplify this one. Now take the our right hand side term, s square minus 2s minus 2 divided by s plus 1 into s minus 1 into s minus 2 equal to, we can write a by s plus 1 first term plus b by s minus 1 second term plus c by s minus 2 third term, which is equation number 1. Now we are going to calculate a, b and c values. What is our left hand side value? That is our numerator term is s square minus 2s minus 2 equal to a into s minus 1, except this s plus 1, we have to write the remaining terms, s minus 1 into s minus 2 plus b into, except this s minus 1, s plus 1 into s minus 2 right here, plus c into, except this s minus 2, write s plus 1 into s minus 1. Okay, now put s is equal to 1 in this equation. If we substitute s is equal to 1 in this equation, we will get first term. If we put here s is equal to 1 means first term will be 0, and also third term also, this one also 0. Okay, now we are going to rewrite the equation by putting s is equal to 1. Left hand side s square minus 2s minus 2 is there. Substitute here s is equal to 1, which is 1 minus 2 into 1 is minus 2 equal to, first term value is 0, because if we put here 1, s is equal to 1, 1 minus 1 will be 0, plus b into 1 plus 1, 2, 1 minus 2 will be minus 1, plus in the third term, if you put s is equal to 1, 1 minus 0, which is 1 minus 1 is 0, plus 0. Okay. So first simplify the left hand side term. 1 minus 2 will be minus 3, because minus 4 plus 1 will be minus 3 equal to 2 into minus 1 is minus 2 into b. Therefore, b equal to 3 by 2. Both sides we can remove the negative sign. Therefore, b equal to 3 by 2. In the similar way, we can find c and a values also. Now, put s is equal to 2 in the same equation. If we put s is equal to 2 in the same equation, we are getting first and second term values are 0, because here s minus 2 is there. S minus 2 means if you put here s is equal to 2, 2 minus 2 will be 0. In the second term also s minus 2 is there. Put s is equal to 2, 2 minus 2 value 0. In the left hand side also substitute here s is equal to 2, which is s square means 2 square is 4, minus 2 into 2 will be minus 4 minus 2 equal to, first and second term values are 0, 0 plus 0 plus c into, put here s is equal to 2, 2 plus 1 is 3 written here, 2 minus 1 is 1 written here. Therefore, we can remove this 4. We are getting minus 2 equal to 3c. Therefore, c is equal to minus 2 by 3. Now, in the same equation, substitute s is equal to minus 1. If you put s is equal to minus 1, in the three terms, second term and third term values are 0, because here s plus 1 is there. Here if you put here s is equal to minus 1, second term is 0. Here also if you put s is equal to minus 1, third term value also 0. Okay, substitute in the left hand side also. Minus 1 whole squared will be plus 1 written here. Minus 2 into minus 1 will be 2. Minus 2 equal to a into, substitute here s is equal to minus 1. Minus 1 is minus 2 written here. Minus 1 minus 2 will be minus 3 written here. And also second and third term values are 0 written here, 0, 0. Therefore, simplify the left hand side term, 2 and 2 opposite sign, we can remove these two terms. Therefore, 1 is equal to minus 2 into minus 3 will be 6. 6 into a, 6a. Therefore, a equal to 1 by 6. Now, we are getting a, b and c values. Now, substitute these three values in equation 1. Okay. The equation 1 becomes L of y of t equal to a by s plus 1. Okay, general equation is a by s plus 1. The value of a is 1 by 6 written here, plus b by s minus 1. b is 3 by 2. Plus c by s minus 2. Here value of c is minus 2 by 3. That is minus 2 by 3 divided by s minus 2. Here in the numerator 1 by 6 is there, no, this is constant, we can write here 1 by 6 into 1 by s plus 1 plus 3 by 2 into 1 by s minus 1 minus 2 by 3 into 1 by s minus 2. Left hand side what is there? L of y of t. Therefore, y of t equal to, we can write L inverse, because left hand side L of y of t, this L goes to right hand side, it will be L inverse. Here 1 by 6 constant, take outside and then apply L inverse. L inverse of 1 by s plus 1 plus 3 by 2 into L inverse of 1 by s minus 1 minus 2 by 3 into L inverse of 1 by s minus 2. Now we are going to apply L inverse formula here. L inverse of 1 by s plus 1 is e power minus t, plus 3 by 2 into L inverse of 1 by s minus 1 is e power t, minus 2 by 3 into L inverse of 1 by s minus 2 is e power 2t. Here we used the formula L inverse of 1 by s plus a is e power minus at. L inverse of 1 by s minus a is e power plus at. You should remember these two formula, then only we can easily apply the formula here, which is the final answer. Y of t equal to e power minus t by 6 plus 3 by 2 into e power t minus 2 by 3 into e power 2t. Okay, next problem. Solve y double dash minus 2y dash plus 2y equal to 0. Then given initial values are y of 0 and y dash of 0 equal to 1. First we are going to write in terms of t. This is our given differential equation. Write in terms of t. Y double dash of t. Then only we can easily apply the Laplace transform formula. Minus 2 into y dash of t plus 2 into y of t equal to 0. And then apply Laplace transform both sides. L of y double dash of t minus 2 into L of y dash of t plus 2 into L of y of t equal to 0. And then apply second derivative and first derivative formula here. We know that the result for L of y double dash of t, s square into L of y of t minus s into y of 0 minus y dash of 0. And also apply L of y dash of t result also here. Minus 2, this 2 is common for all. Minus 2 into L of s into L of y of t minus y of 0 plus 2 into L of y of t equal to 0. Now we are going to apply our given initial values, which is y of 0 equal to and y dash of 0 equal to 1. Substitute here. Here y of 0, substitute here y of 0 is 1, y dash of 0 also 1. Here one y of 0 is there. which is 2 into 1, because here one minus 2 is there, here one negative sign is there, which is positive, plus 2 into 1. Okay, and then rest of the terms, s square into L of y of t minus 2 into s into L of y of t is here, and also 2 into L of y of t, our last term here. Now from these three terms, first term, second term, third term, from these three terms taking outside common L of y of t, and here L of y of t common means here s square is there right here, here one minus 2s is there right here, here one plus 2 is there right here, and then rest of the terms minus s, here one minus 1 is there, here one plus 2 is there, which is 2 minus 1 will be plus 1 equal to plus 1 equal to 0. See, look at this, here 1 plus 2, here 1 minus 1, 2 minus 1 will be 1 equal to 0. Therefore, L of y of t into s square minus 2s plus 2 equal to, this minus s plus 1 goes to right hand side, it will be s minus 1. Therefore, L of y of t equal to, we can write s minus 1 by s square minus 2s plus 2. Now, this can be written as s minus 1 divided by s square minus 2s plus 2 is s minus 1 whole square plus 1. If we write in this form, we can easily apply the Laplace transform. If you expand this one, what is s minus 1 whole square? Just like a minus b whole square form, which is a square plus b square minus 2ab. Minus 2s is there, plus 1 is there. No, here 2 is there. That's why we written plus 1 here. Okay, now we can apply our direct Laplace transform formula. What is our left hand side term? L of y of t. In this problem, we no need to apply partial fraction method, because we are getting here a direct formula format only. That's why we can apply our Laplace transform formula directly. This which is equal to, we can write y of t equal to, this L goes to right hand side, it will be L inverse. L inverse of s minus 1 divided by s minus 1 whole squared plus 1. Okay. Now apply L inverse formula. This formula format is L inverse of s minus a by s minus a whole squared plus b square, which is equal to, we can write e power at into L inverse of s by s square plus b square. Now we can write e power at into, we know that L inverse of s by s square plus b square is cos bt. Okay, e power at into cos bt formula. Apply this formula here. First you remove this minus 1. Here 1 minus 1 is there, no? Both the numerator and denominator term, remove this minus 1, which is e power t. E power t into, we can write L inverse of s by s square plus 1. Okay, which is equal to, we can write e power t into cos t, because here b is b square is 1 only is there, look like this 1 square, that is b is 1. We can write cos t, e power t into cos t. That's all.